We are very excited to have Dr. Rajendran from Syngene International with us. He is going to present on ICM Chemist for Medicinal Chemistry project in CRO, challenges and opportunities. Dr. Rajendran completed his PhD in organic chemistry from IIT Bombay and later pursued his postdoctoral research at the University of Regensburg in Germany. He joined Syngene International in 2010 and have been a part of the organization since then. Please join me in welcoming Dr. Rajendran with a huge round of applause.
Good afternoon, everybody. So, first disclaimer, I am not a computational chemist. I am the organic chemist. By practice, I am doing the medicinal chemistry. Now, I am learning the new tools in the organic medicinal chemistry, whatever the tools they are using. Basically, the idea is we want to communicate with the CAD team so that we should understand the basic things so that we can clearly talk with them. That is the purpose of the understanding. So we are working in the CRO. So if you see the CRO, so if you are working in the CRO environment, especially the medicinal chemistry, it comes with its own challenges. For example, the main challenges is the speed. So we used to get the data continuously. We need to take the decision quickly, sometimes in a day. So we need to understand the SAR rapidly, and we have to design new molecule for the next set of round. The other problem is that we used to work on multiple projects, multiple scaffold, and also those all are in the different stage. Suppose if you are not knowing the 3D interaction, the 3D view, so you can't able to design anything by logic. So that is the another thing. So the third most thing is that sometimes we not able to get the complete detail about the project. Sometimes your project is not having the structural data, so that some tools we need to understand the binding, even the limited data. So that highlights that we need some tools for our medicinal chemistry projects to enhance our research. So it will decide our work how to do. So if you see this diagram, so the medicinal chemistry effort, so across the different stage of the drug discovery, you can see this 30% of our work goes for ADME property administration. So here we need to lead the lead optimization, the 25% for structural based design. Here we optimize the heat by understanding the ligand interaction. So then it is for the SAR analysis. So it will tell how small changes affect the bioavailability. The another main part is that synthetic feasibility. No, whatever the design if you are making, we have to bring into the vial. So I think you heard some ad. So some person is explaining about all the cutting edge technology of the ship, everything. Finally, he will ask kitna deta hai. So whatever design you make it, so how many compound you are bringing into the vial. That is the main important in our CRO. The other one is for project management. Here the project management we used to do the documentation, communication with the other. That is the main area. So in this scenario, if you look at some tools, so we are looking for some tools to help us to our day-to-day life and solve our problems. So with that, so what we need from that particular tools, that is easy to use, and it will give you our clear 3D view model and also fast property prediction. Then again the virtual enumeration and powerful spreadsheet for manage our structure properties and the SAR. So clear communication with our CAD colleague. So in that one, we are requesting our informatics team. So our Achandya lead by informatics team, they recommended us for ICM Chemist Pro. So this ICM Chemist Pro, once we got it, what basically we done it, we not jump into all the designing part and other things. Normally what we used to do, we read the medicinal chemistry papers. So all the time the author thinking about in the 3D point of view, he write anything about the manuscript. So even though he giving some clear picture about that binding pocket, everything, we not able to understand. So that time what we used to, when we are reading the paper, we take it out the PDP, then you use that ICM Chemist Pro for visualizing. So it will give you the better understanding of what author was telling. So in this regard, if you see the binding pocket visualization, it will give you the clear idea about the binding pocket. And also it will tell about what are the key interactions and also what is the shape and what is the volume. So all the detail it will give you. and also more importantly, it will give you about what hydrogen bonding, where the hydrogen bonding, what distance, whether it is strong or weak, all the detail we can clearly visualize, we can understand the what author was expected to say in that paper. That is very important for us to understand further and develop. And also it is the electrostatic interaction and also hydrophobic contacts, how it will look in that out. So first we will understand this one, we try to implement this one for our optimization. Also this will predict the clash, so where the steric will not be tolerated, those things also it will predict. So it will give you for designing, so which molecule we have to put there, whether smaller group or bulky group or other things. Also it is giving the identification of the growth vector. So normally morning Achindya talk about that ADC or the PROTAC, so where we want to grow our connecting vector. So that also we can predict from the ICM. So next one is that it will give you the lot of multiple poses. So with that we can validate the docking, then we can find out which ligand pose is good for us, that we can do it for this. The another one was the property prediction. So when in the CRO we used to get lot of compounds. So we used to predict the property of the ADME property, physiochemical properties, and also we can go for like log P, log pKa, those things. So it will give you, before going for synthesis, it will give you the profile about the compound. So it will help us to prioritize the compound. Also this MPO score, especially when you are working for CNS project, we want to prioritize the compound based on the data. So it will, MPO score will give you the calculator, the predicted property, it will give you the single ranking. So you can see that which molecule possesses the balanced property, so that we can go for the prioritize. So then we can workflow, what we used to do, we can with this data we can go for confidently prioritize the compound, then we can efficiently analyze the series, and also we go for the synthesis, and also we can take some go no go decision based on that. Obviously this accuracy is moderate to it's moderately high, especially for the same chemical space. Also it is good for the trend analysis. Of course the final outcome will come from experimental data, then we can correlate with our data, then you can proceed further. This is about all the property prediction. The another area where the ICM chemist enhanced our chemist and the CAD team collaboration is the its spreadsheet interface and the library enumeration. In the spreadsheet, we have lot of data set and also lot of chemical data. So ICM chemist, this interface will help us to manage those things. In the one place we can see the chemical data, chemical structure, activity data, as well as your predicted data, so that you can interact with your CAD colleague very nicely, and also you can do the lot of filtering. So it is helpful for the, very useful for when you are discussing with your computational colleague. The other one was library enumeration. So this library enumeration will useful for sometimes if we have lot of library, like even in-house we have something, if you want to do acetamine coupling, you have in-house lot of compound. So you take the acid and amine, you can couple it and you can get all the compound, and you can analyze the data. So you can predict the data. So with that, even though you have n number of compound, with the predicting the data with the ICM chemistry, you can shortlist a few compound, you can go for it. Then you can check whether the prediction is okay or not. At least start with this library enumeration will help us. Next one was, this is for chemist CAD collaboration. Most of the time, so when you want to, your project will be successful, we need to be collaborate efficiently with your CAD teams. Suppose in the chemistry team, we know that how the molecule we can synthesis, how the scaffold will behave, where you want to modification easier. So those detail this. Your computational chemics know that where that your energetics data about that one, how the molecule behaves, structural data, then docking forces. So you both will discuss on same time. So this ICM chemist platform, bring this platform, we can discuss both. We can check the structure activity, it's a ligand protein interaction, then we can check that which molecule we can take it further. So those things we can discuss. So you no need to back and forth. First the chemist will send it to you, then you have to discuss, then you have to check separately. Instead of that, we can work together and you can sort it out, all those things. So it will bring you some different language for between chemist and the CAD team. So we can shorten our workflow. and we can speed up our synthesis, because in CRO everything speed we need. So we have to design everything speed. So that's why we are working with this ICM Chemist. So why we are choosing ICM Chemist? It is lightweight, and also this fast 2D and 3D editing is there, and real time we can visualize the pocket visualization. So yes, nicely with collaborate with your CAD team. So this is excellent for the medicinal chemist, since we want to know only the how it ligand interaction and a few details. We don't want to go further experiment with docking other things. So with that, ICM chemistry is useful for us. And with this, actually I am not showing this my case study, since I didn't get the approval. So with this case study which Achandya team we collaborated, we bring some molecule in the client comes up with the molecule with the millimole level only the activity. Then we did with the ICM Chemist. Then finally we come up with the molecule with the nanomolar level with the good property, and also the further went with off target identification also we have done it. Then finally that molecule in the good position now. So this with this note, actually a lot of things are there, and also some challenges with ICM Chemist is that sometimes it is non-computational chemist, still we have to go for a lot of YouTube videos, then user guide, then only we are understanding about that one. So sometimes when you are using the large data set, sometimes what we used to do when the project comes, we take the data from the reaxis, or sometimes if the target is well known, you have multiple data set points. So with analyzing the data set point, there are some issue will be there, that slowness, and also this protein preparation is still not good for the chemist point of view. Maybe it is computational chemist, it is good. Then limited automation, and there is, from my point of view, there is not connection with ELAN. So these are the few limitation with the ICM Chemist flow. With that note, thank you for Advent and Syngene, and also especially for Achandya team colleagues, Soumya and the former colleagues Soumya and Anjali, Achandya and Vengat, those who are helping us for understanding this ICM Chemist Pro software thoroughly. Thank you.
Thank you, Dr. Rajendran, for this wonderful presentation.